Yeah, hey guys. My name is Viktor. I'm actually a bit foreigner, so I do my presentation in English. And today I really like to talk with you about quality assurance and machine learning. And both of the things is very big and very complicated. Because when we talk about quality assurance, we can talk about unit test, integration test, about a system test, or else we can talk about some automation and manual analysis, or either some code review. Again, performance, security, reliability, this is all about quality assurance. And it makes quality assurance really, really big and wide. And instead of going through all those possibilities, I'd like to define quality assurance for machine learning as a set of practices that allow us to assess state of the product and to improve the state. And quality assurance practices will start from the very beginning of the project, will go through the whole life cycle, and end with a feedback from end user, feedback from production. Again, machine learning is even wider field than quality assurance. Usually, when we talk about machine learning, we can talk about some prediction, some recognition, natural language processing. If you play games, you totally know about some bots and artificial intelligence in the computer games, in chess, Go, stuff like this. My personal experience lies in natural language processing, and you may even know the functionality that we're working on. If you have your Google account, and if you receive a reservation email on your Google account with a hotel or flight, and your mail asks you, hey, do you want me to add this information to your calendar? This is exactly natural language processing, and this is what our functionality does. So we extract the data from your email, we analyze this data, and we build an object from this email. And this object then can be used by a third party. For example, it could be object to calendar, or it could be item in our application, something like this. So when we talk about set of practices and we talk about quality assurance for machine learning projects, we have to know that biggest work in machine learning projects is work about gathering the data, assessing the data, pre-processing, post-processing, so a lot of different manipulation with the data. So that's why today I want to focus on the assessment of the data. You know, with a regular project, we usually get the data to do the tests. In machine learning, it's vice versa. We're doing our test to test the data, to assess the data. So first and easiest way to do so, it's an expert. When we have our project, we usually have this project in some domain. It either can be medicine, so we, for example, recognize some disease. We can predict correctness of this disease. For example, most common is a cancer, right? We have prediction of whether it's cancer or not. Or another common problem is equipment. We have set of characteristics of the equipment, and this equipment plays all over the world. And machine learning system, based on those characteristics and based on historical data, predict when this equipment could be broken to send in advance someone who will fix this. So to do so, we need an expert. And through all our system building, we will have a lot of communication with an expert. And the best way to have is a human expert. But sometimes, and especially in my project, human expert is not the case. Because I just don't need anyone who will do email reading for me. I don't know anyone who is an expert in email reading, right? So in this case, what we can do, we can build an expert. It's important to understand that build that expert our application expert will not able to handle missing data, because we can't test something that is not there. But what it can handle for us, it can handle overwhelming data. When we do our project, we can have lot different parameters, and we don't need to assess all of them. Otherwise, it will just take our performance, our time, and it would be bad for us. So let's go through an example. Who of you guys has an experience in machine learning for more than 2 years? Oh, good to know. So probably I can't give you anything important during my presentation. And who of you guys has less than 2 years or non-experience in machine learning? Okay. It is good. It is good because my presentation is for you, for people who are interested in the field and who want to know how it's going on. So let's start from building a simple model. Model is how we call our application in machine learning. And to build a model, we need a data. So you can see here a data, our parameters. We need the task that we're going to solve. In our case, we're going to predict whether or not this person is sick and whether or not this person has a flu, right? This is our hypothesis. Our hypothesis, which is Y, that person has a flu. 0 person doesn't have a flu. 1 person has a flu. We need parameters. We call these parameters features. So first feature is a fever. It's our x1. 0, we don't have a fever. 1, we have a fever. Aches is our x2. Chills is our x3. And also, doctor measure blood pressure. So for blood pressure, we actually have 2 parameters because, blood pressure is like 120 on 80, right? Something like this. So that's why we have 2 parameters for blood pressure. So in this case, we have our hypothesis. And our hypothesis is Y. And we have 5 different parameters. In real example, it would be like 500 different parameters. And we don't able to process all of these parameters. So instead of going and processing all of these parameters and try to work with them, we build a very simple algorithm, basically already machine learning model. This algorithm, what it's going to do, it's going to reduce number of parameters for us. Why do we need it? Because we want to have faster learning, right? Later on. To do faster learning later on, we need to invest right now into parameters. So we have 5 parameters: fever, ache, chill, and blood pressure. Blood pressure is 2 parameters. We see that blood pressure is mostly stable one, right? Like all the time it's stable. So whenever a person comes to us with a flu, blood pressure has no influence on the flu, actually. So those simple algorithms that we build, using, actually for scikit, it's built-in algorithm. We just give parameters to scikit, that's it. It's going to process it for us. So what it does, it's find the parameters with low variance, right? And remove those 2 parameters, that's it. We just got our 3 parameters that matters. And what we did next, we make a model, very simple model with, we evaluate our hypothesis, first for all 5 parameters, second for 3 parameters, and we achieve the same result. So in our case, it means that we remove 2 parameters, we improve performance of our application, and just test our data. Another interesting thing in working with machine learning and testing the data is visualization. it's from my personal experience. We work with a text, so it's kind of tricky to visualize, to draw text, right? Still, we are able to find our tokens in the text. I know it's not really best quality, but just believe me, we have a tokens. And these tokens is color in the text. We just draw them. And by drawing these tokens, we just see in the text that person and location together is an airport. So when we have, for example, Krakow, Jan Paweł II, it's an airport. It's not a person and location. Or Warsaw Shopping, again, it's an airport. So just visualizing our data, we were able to build a new feature. We were able to say, oh, guys, a combination of these two, it's an airport. So a second very important thing in machine learning, whatever data you have, to assess the data, to see how it works, draw it somehow. Either you can draw it like this or like this, anyhow, just visualize. Yeah. And then let's say we build our model, right? We remove useless data. Now we need to assess whether or not we have enough data, whether or not we have enough parameters or features. To do so, the easiest way, instead of actually training a model and going through all this machine learning stuff, we just go to an expert. We come to an expert and say, hey, we have green lawn object in the water. It's a crocodile. Expert answer, no, I don't know. So this answer is, I don't know. It's an indicator for us that we miss a feature, we miss the parameters. So we talk together with an expert, just talk, no coding, and say, okay, then we have green lawn object in the water with a teeth, and this is a crocodile. The expert says, oh yeah, this is a crocodile. So you see, just through talk, just through making a statement, we were able to assess our data, and we were able to find the missing features. Yeah. Then next problem, when we finally get our data, when we finally get our features, we need to train a model. To train a model, we need a lot of samples. And with the samples, we got a next problem. Samples could be missed. Best way for us if only part of the samples is missed, and we can replace the samples. Easiest way to replace the samples is just average imputation. This method only calculate an average values, because in machine learning algorithm, everything is a number. So we able to calculate a mean value, average value, whatever, and we just place these values. And as you can see on this tiny red line, it's almost there. It's almost there. What it gives us more samples to train our model, to generalize it better. Yeah, sure. No, this average imputation, it's actually not about model. It's about simple calculation. Yeah. Yeah. What you say about having a model to build a model, yes, it's another way. It's called multiple imputation, and it's true. We can train our model on our Y's, right, to predict our X's. It's a possibility. It's a possibility. Instead of building our application, we again go through a very simple and small model. We train it and say, hey, try to predict our samples. Then again, it's very important to draw our prediction. And as you can see, it's mostly good enough, again, to use it to replace these missing samples. Why we did it? We did it because we need a lot of data to train our model. Biggest problem for production is when we need to resolve a complicated task, when we have a complicated problem, we need to go through a very complicated model. Complicated model meaning that we have a lot of different layers, or we have combination of different algorithms, you know. And to train this model, we need a lot of samples. Otherwise, we either going to have high bias or high variance. High variance mean that we may go and we may guess what we want to guess, but it's going to be like once upon a time. And it's not what we need. Or having a high bias but low variance, we will have our guess pretty strict, but wrong. So idea is to have low variance and low bias. And to achieve this, we need enough samples. Because model starts from training from this, then it goes to something like this, and should go here, or it could appear here. So to remove this high variance and high bias, we need to train the model. But sometimes we don't have enough samples, and when it goes not through the missing samples from the very big set, but instead from the very small set, there is a way to avoid this. This way called transfer learning. It's kind of very rare opportunity, honestly. Generally, if you don't have enough samples, it's time for you to say stop, come to your manager and say, we can't do this project because we don't have enough data. But if manager says, you know, anyway, if you can't do it, we all going to quit. In this case, you can try and do transfer learning. Idea of transfer learning is a combination of already done smart generic model and add your simple task to this smart generic model. For example, let's assume we have a mobile phone that's able to recognize a face, right? And we need to add recognition of the glasses on the face. So this generic model would be recognition of the face. And this simple task that we want to add, it's glasses. How it works in reality. Let's say we have enough samples in general, and we want to predict sentiment of a sentence. Basically, a sentiment is positive, negative feedback on Apple Store, Google Market, or in Twitter, whatever. It's a very common task to analyze sentiment. Why we do this? Because we want to gather some opinion about us, about our application. And the general problem that most of these feedbacks has no clear sentiment. In our case, we say, let's say we have 62 not assigned sentiments. So this is going to be our generic model. We're going to train our generic model to understand statements and to understand how our words in statements works together. I will show you in a few seconds. And a small amount of samples we're going to use to actually train our small model to understand whether or not word is positive or negative. So how it works? Let's say we have a sentence. It was great, loved it. First model know nothing about sentiment, but it knows about sentence. So first model will be able to be trained to understand that the word great and word loved are coupled together. That's it. First model doesn't understand whether it's positive, negative. It's only able to remove those words that can't have a sentiment. It's like it, was, of, and build together words that can have sentiments. Another example would be like, hey, it's a bomb, run, run, run. So you see, it's a negative statement. We can't say right now it's a negative, but we can couple this bomb and run. Or otherwise, oh, it was a bomb, I really like it. So it's like, it's blow up my mind, you know. So second algorithm, stupid, really stupid, because without samples we can't make it smart. But it's stupid, it's smart enough to understand whether positive or negative word is. So when we combine those two, we will be able to find an important words in a statement, in a sentence. We will be able to say that these words somehow together, and we will be able then to analyze just those simple words. So what we did, we actually combined those two models. First goes first, second gather words from the first and just assign the sentiments to them. That's it. Again, this method is really interesting. I really like it, but it's almost useless. Only 5% of the real model can be done this way. And the next, but most important thing in machine learning, your application going to mutate, your application going to degrade. So with machine learning projects, as soon as you go to production, your application starts to lose a value. Because in our case, what we doing in a project, we doing parsing of emails. So we try to parse emails from different providers, right? Provider agnostic. But when new providers come, or when, for example, someone starts to send pictures instead of text and email, our model immediately don't know what to do with this. And it's immediately our application goes down, immediately it degrades. So on production, your data mutate, and you need to be ready to do mutation testing. So you need to monitor production, but not only monitor production as like state of performance, scalability, whatever, but you will need to gather your features again. You will need to gather your samples again and again, assess them somehow. In our case, we do it manually, and then retrain your model. So be ready if you go with machine learning, you will need to support your project for a very long time. Small tips about prototyping. As I said, my main idea was to talk about data and assessment of data, but I also know that there is a lot of talks about how to do machine learning projects. And if you were working in a big corporation, if you were working with architects, those architects usually push this, let's do it right, let's build an architecture and then build a model into this architecture. So basically, it's kind of not the best approach. Best approach is to do it quick and dirty and fast. And best approach to ignore what kind of language you're going to use, what kind of framework you're going to use. Use the one that you like. That's it. That's my recommendation. Use the one that you like and use the one that can draw the better picture. Really. Because out of those pictures, you will get more information than out of your architecture. And don't be afraid to use even different one to build different models. Because as soon as you do this, as soon as you stop with your model, then you will be able to build your application. But it's a great chance that this application will never be built because you just can't train your model good enough. So, small conclusion. Visualize your data, even if it's a text. Be flexible. Do prototypes. And fight fire with the fire, which I mean do a simple models before you get your big model. And the simple models, be ready that they help you to work with your data, with your algorithm, and so on. So that's it. Any questions? Okay. Yeah, feel free. So thank you.